Hi everyone. Today I will be showing you how to build an LLM application from scratch using Python and of course using libraries like Hugging Face and OpenAI. We will base this around the real world call center scripts English dataset that comes from Hugging Face. There's over 91,000 high quality transcripts that come from this dataset. We'll be zoning in on the automotive and healthcare call center transcripts portion of the data set. And just for your perspective, so when I'm talking about automotive and healthcare insurance, here are like some of the typical companies that you'll see: USAA, Farmers Insurance, Geico, Allstate, World Insurance Associates, Anthem, and so on. So next, what we're going to be doing is creating a new GitHub repository. So automotive, healthcare. We can call this LLM as well. And so that's pretty much what we'll be doing. Public repository, license, we'll just ignore that. To git ignore, we'll use the default Python and we'll create the README. And you will need a GitHub profile and set up a SSH key and all that. Once you've done that, it should be pretty straightforward. So we're just going to clone our new GitHub repo. Okay, and what we're also going to have expected is that you install Anaconda, Miniconda, some virtual environment tool, and we'll create a new virtual environment. We'll call this LLM Live, and we will set Python to 3.14, which is one of the newer versions. Let that run and install necessary packages to start us off. Again, here's another pointer to that. And the automotive healthcare insurance. And here's what the JSON transcript file looks like. We have our overall text, and then we have the words, broken apart and a whole bunch of extra metadata for that. And we just cloned our repo. So create a source directory, create main. The other that we'll need is in the root of our repo directory, we can have an environment file. And so first off, what I'll do is I'll list out the steps to build out the LLM application. We have our config and the environment variables. And the second one, the auto code completion can be useful, but for our purpose, for now, I'll just snooze it for like 30 minutes. And the second step will be the taxonomy. So those are going to be like the intent labels. We'll come back to that. And then after that will be the schemas. And then the next one will be interfaces. And then we will want to create our prompt builder. And 6 will be the HF provider, which in our case for now we'll use OpenAI, but there is also Hugging Face's one. And then of course there is, where we could do a REST API, but for now we'll focus on OpenAI. 7, there will be validation steps that typically relate to extracting the JSON from when we summarize the text from our transcript. That's typically in JSON format, and we want to be able to extract the JSON. And then we'll also have like a coerce to LLM result That'll be based on like one of our schemas here too, so we can get it in a nice, properly structured format. And then storage. So for our case, right at this moment, we'll use Supabase, and there are typically two approaches we can take. One is through making a REST API call, and the other is to use the Supabase Pi library. For our case, we'll just use the REST API. We could later revisit the Supabase Pi. And the next step is going to be our pipeline. So this is going to be like a call processor. It'll connect all of our different components of the data pipeline so that we can receive the data, JSON transcripts, either like a single JSON transcript or a directory of JSON transcripts, like you saw earlier. And then we can, pass it through our LLM model as we make an API call using OpenAI client. And then we can generate, summarize the transcript, put that into an LLM result, and then we can, at the end, print it, or in this case, like push it up to our REST API call to Supabase with an upsert call. And the 10th step will be an entry point, so we can deploy everything. So some of the environment variables we're looking at, and I'll move this to the environment file, HF token. Then we have HF followed by the model ID. And I'll show where we can get these as well. And then, of course, Supabase related. So this will be related to like our Supabase project. And this will be where we'll create an SQL table. Supabase manages Postgres databases and tables in the cloud. And then with Supabase, we have also the table name. So, the simple one would be call summary. But since we already know we're dealing with like automotive and healthcare, we'll say AH call summary. We'll do something like that. And then we have one more Supabase, which is the secret key. So the nice thing about this is we can bypass the typical RLS policies that would be required for interacting with Postgres databases and tables. We can also use something that's Supabase publishable, but that requires managing the RLS policies. So for simplicity, we'll use the Supabase secret key. And then we can start moving some of these to our environment.env file. So I'll just say moved environment variables to .env file. Put it here. Okay, and for your reference, I can go into HF token, right? So this is where I currently have a token. What I'll do is we can edit, so we can just click on invalidate and refresh. Oh, I might need to. Okay, so we logged back in. We can do an invalidate refresh. So here's my new base token. Yes, we're still here. We can go back to Hugging Face. Now, the thing with this is you don't want to show your Hugging Face access token to anyone. So like after this, step-by-step video, I will also delete this access key. And so we can come back here. We can get the token. I'll make a note as well. Don't share with people. Temporary for video. And then the model ID. So where we can get the model ID is related to Hugging Face models. So you could do a Google search, Hugging Face models, find it. There's all these different models. We're going to take one of the text generation ones, 20B or the 120B. Of course, 120B is a bit bigger. So we'll just open a new tab there and copy it. There's more information about that model. So we'll pass that as we create our OpenAI client later. That's wrapped around Hugging Face class that will create the Supabase URL. So the Supabase URL. So initially I had insurance call summaries. What I'll do is I'll create a new project. And instead of that, we'll say auto health insurance call summaries. And typically they recommend you create some password with it. Let's see, enable automatic create an event trigger that automatically enables row security on all. We'll ignore that one. And then there's, we're doing Postgres. Let's see. Okay, so we'll generate a password. Again, don't show anyone the password, but for the video's purposes, I will keep the password here, and then I will remove that table. I'll remove that Supabase project, Supabase password. I'll come back to it if needed. So we can create okay, so now I have the auto health insurance call summaries. What they're asking for that we need, of course, is the project URL. So we can bring that in. We'll create this table later. And publishable key is great, but we're going to use the secret key. So we'll go into API keys. We're going to copy our secret key. All right, so now we have the environment variables that we'll need. We'll load this in Python later. Okay, so now we can focus on taxonomy. So one of the things is like when we read through the description, in certain cases, we may be able to identify like intent labels, for a call center, cancellation request, billing payment, amount, policy change, those different things. We'll do some general ones. Oh, and then like what can happen with this too is if you want to go even more in depth, you can have a parent list that's simple, but then you can have that point to map to another list that goes even more specific. It's on the taxonomies as well. But for now, we'll just do cancellation request. And maybe there's like a reshop rate for the automotive and the healthcare insurance. Or billing payment. Claim status. And we could have like new quotes. Maybe it's for your auto part of the insurance or the healthcare insurance. General inquiry. And of course, as the domains expand, we may go into like this other category for taxonomy intent label. And so like as we get more specific, we're going to do more domains, we can also add more taxonomies to the list. And note, we could have a secondary, list of taxonomies that the parent wants to. And these can go more in depth. So like cancellation request, you have another list with particular terms, reshop rate, another list with particular terms, and so on. So for this next step, we are going to use the Pydantic library. So there's going to be multiple libraries we need. I'll try to just install them as we're going through the process of writing out the code. So I'll write a note here, Pydantic, and that'll just be a pip install there. So now we can activate our LLM live on the environment. We can also install Pydantic. So what that'll come with is from Pydantic import base model. And one of the classes that we'll utilize for our schema, call event, and have it inherit the base model. And some attributes in here, call ID, for instance, another is going to be the transcript, and another could be the metadata, and this could be a dictionary, string, and any, and then we can have this set to field, pass in default factory equals dictionary. So I'll get dictionary and field real quick. So let's go to a Python import field. So field comes from, Pydantic. From Pydantic import field. Pydantic import field. Similar case for the dictionary. So if we look for field and then Pydantic. This model and then from typing import. Okay, let me get that. So from typing. So from typing import the dictionary. Double check about any typical process just to check real quick. From typing import any. So those will be accounted for. And from Pydantic, of course, those will be fine. Okay, so after that, we have a status literal list that includes open, resolved, follow-up. And the first class that we'll look at creating soon will be key entities. And we'll revisit this momentarily. And then the other is the LLM result. And this is so that we can keep things structured. We'll revisit that as well. And then interfaces. So for example, with the HF provider, we're using OpenAI, but I did mention how we could also use a Hugging Face client approach, and we could even use a REST API approach. So these are going to be our parent classes. And we're going to want to import from ABC, import ABC, and look at abstract method. So we can start with our LLM client, have it inherit from ABC. And in the meantime, I will, put pass there, but I'll come back to it as I implement the child classes, and then we can also finish setting up these parent classes. And the other one, of course, is the storage client. So this will be, based on Supabase, but, we could also use other, cloud data storage related services that are available. For our case, though, we'd be looking at Supabase using the REST API call. Alternatively, we could use the Supabase Python client as well. And then we'll revisit that. We will now work on the function called build prompt. This is going to take two arguments. One is going to be the transcript, which we will get from our JSON transcript file, or any of the files in that directory. And we'll use like type hints, so string, and the other is taxonomy. So this is a list. And so what we'll be returning is a string. This is going to be our prompt that we're going to instruct the LLM model to follow tasks step by step that we set. Taxonomy string equals. So we're going to do double quotes followed by comma, and we want to join the string we create on that from the taxonomy list. So we get the taxonomy string. Those are our intent labels from earlier, and we can return our prompt that we're going to provide later to our LLM. So you are a full center transcripts processor. Transcript processor for an insurance. Yeah, we'll keep it like that. For an insurance company. We're dealing with automotive and healthcare insurance companies. The task at hand is summarize the conversation concisely. Second to that is choose the single best intent label from this allowed list, being the taxonomy list. 3, extract key entities. If they are present. And so one of them could be the policy number, the other could be claim ID, effective date, and the amount. Say like the amount that was charged to the customer for the insurance, or the amount that maybe there was like a reimbursement from the insurance company to the customer. And then we will also task it with provide action items, and the other part, provide action items and a status. Output format. So the output format is returns only a valid JSON. So like no markdown, no backticks, and must match this JSON schema exactly. And here's the schema. Of course, depending on, what sometimes maybe customers or problems may provide with like what the expected output schema would be for the LLM model's result. We're just going to go with, this particular one, which will suit our case in the meantime. So we're going to, have it generate a summary of the transcript. And we're going to also have it bring in the intent label. So this could be a label from this allowed, from the allowed list of labels, which was our taxonomy. And then the next one is confidence score, as in the LM model generated a summary of the transcript. How confident is it? Initially, we'll start out with 0, and that will change based on what the LM model provides. And now we have key entities. Maybe there's a policy number, that could be relevant. Then there could be a claim ID. The other could be effective date, maybe the date where the person's auto insurance, took effect. They had access to it, whether it's it could be auto insurance or health insurance. And then the other is the amount. And so that's key entities. The next field we could look at is action items. And this could be a list of strings, for instance. And then after that, we have status. So we have open as an option, we could have resolved as another, and follow up to the status of, maybe it's like someone's insurance claim. What was the status on that? Okay, and then we can come in a moment, we'll go back to those schemas that we were looking at, but I'll wrap this up in the prompt. Transcript being the original transcript, and here's our transcript. We're going to call strip on the string to remove beginning and trailing, white spaces typically. And then the entities. So we'll just bring that here for reference. So summary, intent label, confidence, action item, status, those are typically related to LLM result. But the key entities portion is, of course, key entities. So we got policy number. Then we have claim ID, effective date, amount. Okay, so after that, we have the summary, of course, intent label, intent confidence. This is float. Say float in the meantime. For intent confidence, and then key entities. Key entities field that came from Pydantic. Default factory equals key entities. Action items. Action items is going to be a list of strings. So to double check there, let's see, import list. That's another. Yeah, from typing, just double checking. We'll put that here. So we import list, string, and field list, and status. We created a status literal at the top there. Oh yeah, I need to also import literal. From typing, get literal. Yeah. So we'll just put that at the front there. So we got the literal, and so we got status is of status type, and then set that to open being the default. So now we have both those. We can remove this reference here that we got as we built out the prompt. So now we have our schemas defined. We'll come back and revisit the interfaces momentarily. We have our build prompt. Now we have the HF provider. So this will be HF OpenAI. We're going to wrap an OpenAI client around what will be primarily like Hugging Face providers, interface class. So HF OpenAI compat clients and LLM client. We'll create our constructor, the init. Okay, and so with this, I also think back to typically like what are some of the environment variables that we're going to use related to like Hugging Face and OpenAI. Um, so of course, one of them is the Hugging Face token, or if we have the OpenAI key, we have that OpenAI key. So we can say token. The other one after that is typically the model ID, and there will be like a base URL typically, because with OpenAI, we're going to have it reach out to the Hugging Face URL where we can have our client make requests out to the LLM models to perform computations. And so that will be a string, and we can also, look up the Hugging Face URL for that. Okay, and then since we're going to be using OpenAI client, we may want to set a timeout. So timeout could be like 20 seconds. That should, I believe, be enough. If we need to, we can update more of the arguments for the constructor. Let's see. So first we'll set our token. So it could be we pass token directly, or we just get it from our environment variable. Alternatively, it could have been OpenAI key, but in our case, we mainly care about the HF token, and then the other one is the model ID, and we have model ID, this environment, and we have HF model ID. Okay, and then we have base URL. We have the timeout. Okay, and then we can create our OpenAI clients. We'll set the base URL followed by the API key, be our token. We'll use the Hugging Face token for that. And then we can do summarize and classify. And what we're looking to summarize and classify will be the transcript, of course. But referring back to the call event schema, that'll also contain like the call ID, the transcript, and optional metadata if needed. So we'll use the call event. We'll also use a type hint for that. And then we can say for this a tuple, which will include like the LLM result and a dictionary string any. This will typically contain like the model raw. So we're going to put our LLM model's output into a nice structured LLM result, but we may want to also refer back to like the original model output. Okay, so then now what we can do is we can assign our prompt from calling build prompt. This is going to take our transcript, so we can pass like the transcript. And the taxonomy based on that taxonomy list that we created earlier. Okay, and then the next part is really like the completion from delegating our OpenAI client to make a REST API call out to one of the LLM models that's like running in the cloud. So got self client chat completions, we use chat completions API and create that. And this is going to be model ID followed by messages. The messages will be in dictionary format. And of course, we're going to pass our prompts so that the LLM model can run the summary and classify operation on it. The role, user, and the content. And then the other will be setting the temperature being like 0.2. We want our LLM model's output to be more deterministic. Typically, the range could be like 0 to 2. Being closer to 0 is more deterministic for the LLM model output, whereas like 2 is more random, which we don't want. And the other is like the max tokens. So in our case, we're going to set that to around 400 to have about 400 characters that are generated in the summary. And finally, we could set like a timeout. So we'll set timeout for that. Okay, and then now we're going to capture the generated text, starting with initializing it, followed by getting the generated text from our OpenAI LLM model's output from the completion. So we can do choices, 0, get the message, get the content. If there is no content, we'll just keep it at the empty string. There could be an exception that could happen, and in that case, we could just assign generated text to the string of completion. And then what we could do is we could get the LLM result from calling coerce to LLM result, and that is where we could pass the generated text as well. We'll implement this function soon. And then the other is the model raw, in case that we want to keep the original generated text from the LLM model's output. And so we got dict, and then we have string any. Okay, and so first we could start with like the provider we're going to use, OpenAI, SDK to href router. If we're using the Hugging Face model, it'll be slightly different, which we could also look at the Hugging Face documentation. Once we have this HF OpenAI compat client, Hugging Face's interface client is very similar. They made sure to make Hugging Face's interface very similar to OpenAI's chat completions API. So we got provider, and then we have model ID. And we have the raw response. So in this case, we could look at getting the attribute and could look at completion. We could try to do model dump. If that doesn't work, what we could do is we could then have a lambda function that just retrieves completion passed in a string, and we just retrieve that. And then of course we'll return the generated text. Okay, and now from the summarize and classify method, we can return the LLM result and the model raw. Okay, so now we have most of the code implemented. Of course, we can finish setting up that LLM client. So really what we're going to get from our child class is the summarize and classify. And then for this case, we'll just put a string there to mention what it returns. And it returns tuple for the LLM results and the model raw. Okay, so the next thing is working on the validation steps. So first we'll be looking at extracting JSON object. Second, we'll look at first to LLM result. So first, what we'll look at is getting import rejects and so JSON. But just in case, I'll put JSON at the top over here because yeah, I'll put it up here. This should be the first place where we end up using the regex expression, so I'll keep it here for now. Recompile, and what we'll pass our regex expression. So this will be backslash followed by dot star 0 or more of any character followed by backslash. So what we're looking at doing is a regex expression to try to extract the pattern that would represent JSON curly braces. And we have the regex.all. And now we can create a function, extract JSON object. And what we'll typically pass here will be the text. It'll be a string. And what we'll return is going to be, but we can double check if I need to update the return type. So typically what I'll try to do is return JSON loads, and it'll be text exception. And then the next step will be to clean. So remove markdown, for instance, remove markdown JSON. You'll see. Cleaned equals text strip. And for removing white spaces related to trailing characters, beginning characters. Cleaned. Replace will include markdown followed by that JSON. So it's a markdown section. That's a markdown JSON section. So we don't have markdown. Of course, we could also look at removing just raw markdown as well. Rid of markdown sections. The other is we're gonna check for match for JSON LLM models output. So I'm gonna check a match, use JSON object, then search clean for that match. If not M, we'll raise awareness on this with a raise runtime error. No match for JSON. Okay, then below return JSON loads if all goes well. And group 0 to get the string of JSON and pass it into JSON loads to load it as a JSON object. And then coerce to LLM result. So coerce to LLM result. And what this will take is the model text. Yeah, dictionary typically represents JSON. The string in any will be like that. This is actually going to return the LLM result. And what we can try is to get the JSON object to colon extract JSON object and pass the model text. If something goes wrong, then we have an exception. And what we can do is return the result, the LLM result object. We can set summary notify the user that we weren't able to parse the transcript. Requires manual review of transcript. The other one, of course, intent label. We can set this to be other intent confidence, given we weren't able to run a summarization. We can say 0 and action items list, a list, and then we can say review transcript and check intent / summary. And the status would be follow up. Ideally, hopefully that doesn't happen and we make it to this next portion of the function where we can enforce the label. So we can set label to be, we can get the label from the JSON object. Label. And we can check if label not in taxonomy list, which is the intent labels list. What we can do then for now is set it to other. So that would be kind of like that case where I was talking about our taxonomy list can continue to expand as we cross into more domains. So then the next one is to extract key entities. So we can do key entities, we can get it from our JSON object, and then we can check if it's an instance, if it's a dictionary. If it's not, we'll just set it to empty. And then this particular case is we'll be returning the LLM result. And part of this will be object get summary. We'll do best case scenario at the moment. So we're just going to get the summary. We're going to get the intent label. We did some enforcement on the label, so we'll use that. Then we're going to get the confidence, the intent confidence. So we'll get it from our JSON object. And that will be intent confidence. After that, we will get the entity, the key entities. Key entities from our schema, we'll initialize that as well. From our key entities, policy number. So this could be key entities get policy number, then claim ID, effective date, effective dates, and the amount. Okay. So after that, we have the action items, of course, and action items is going to be string x will loop across 4x, and ideally we'll get from our JSON object action items. For some reason it's not, or empty list. If so, 4x in the JSON objects x action items. Then after that, we'll have an if condition to check if we can on the x, pass it into string and then strip that, and if that succeeds, then we'll create the list of string x's, or the list of actions, and then we'll have status. Status will be we're going to get status from our JSON object. We're going to then check if the status the JSON object is in. Similar to the status literal list that we created earlier, but we'll just write it out here. So open resolved follow up. And I mean, if it's true, then we get status. If it's not, we'll just default to open. And then we can return the LLM result. So this is the LLM result. Once we have the LLM result, now we're ready to move on to the storage portion. And there's two parts to this. What I'll do first is I'll create the storage rest, I'll say Supabase rest storage class. And then the second part will be to create the table that I had mentioned earlier. I believe was Automotive, Healthcare, all summaries. We'll create a table with that naming. So we got Supabase rest storage client. We can create our constructor from the init. And what we can do following that is we can think back to, again, what were the Supabase related environment variables as well, because we'll be using those. So, of course, one of them was that URL, Supabase URL. The other was the Supabase table. The other was the Supabase secret key. So we could call this key. And then since we're going to be using, REST API call to do upsert operations on the Supabase table, one area we'll need is like the timeout. Set that to 20 seconds. And then the other part is going to be potentially like the retries. Set that to 2. Okay, so then the next one is the URL. So we got URL for environment and Supabase URL. And we could do our strip. So the last / would be removed from the URL. And then the other is the table. It's a table, or we can try to get it from the environment variable. Of course, we also know what we're calling the table, which was call summaries. Key. So if we pass the key, or we can just Supabase secret key. Okay, and so we have that. Then we can do timeout, set timeout, and then max retries. Okay, so we have the assign max retries. Okay, so we have it. We can define this other function, which is the upsert call. Or it's upsert URL, we could say. So this one, we could actually do a Google search to find what is the appropriate API call, the REST API call, to do an upsert operation on Supabase. So let's write a note. And then we'll just kind of go back and check the code for Supabase and OpenAI client to make sure I updated those URLs appropriately. So what is the appropriate URL or upsert call to Supabase via REST API call? So for now, I'll just do that. But I could see that including the URL that we have, it could include the table, and then maybe there'll be like some call ID that's included in there as well. Okay, and the next one is upsert call summary. And the upsert call summary. Typically what we'll do is we'll pass a record. The record will be dictionary string any, and in this case we won't return none, but this record will be marked as a payload, and we can pass it into dictionary just to make sure. The other one that comes to mind too is we'll need the call ID to go along with the upsert call over REST API that we're going to be making. So the call ID we can get from our event call ID, and we can add a new field for our payload dictionary, call it call ID, and get event call ID to set that. Now what we can do is we can create our headers dictionary. So this is going to include like the API key. So the key, it's also going to include the authorization and bearer, and this will be self key. And the other is content type application JSON. And the other is what we're going to have as a preferred operation. So resolution, if there's ever a conflict on what we try to upsert call summary to our existing Supabase Postgres table, we're going to merge duplicates and return. So the next part is going to be we're going to try to make attempts to perform the REST API call for upsert call summary to our Supabase table. And so sometimes we might run into errors. So we'll say last error, we'll give a type hint of exception. Initially, we'll set it to none. And then we'll have a loop on attempt in range self max retries plus 1. And so what we're going to try to do, we would try step conception T pass. So we'll get a response when we make our requests API call. So we're going to use requests library. So this reminds me I will need to pip install requests. It also reminds me I will need to pretty much pip install OpenAI. With that, I should also install Hugging Face Hub. So we'll get those in there real quick. Okay, Hugging Face Hub. And pip install requests. Supabase storage. We're going to use requests to make a post call. And of course, the code completion is back on. Again, I'll deactivate it for now, 15 minutes. So we can, like it showed, pass the upsert URL. And then the next thing is going to be the headers that we just set. Okay, and then we're going to also set a JSON. We're going to assign it with our payload. And then we'll set a timeout. Okay, and so what's optional is if we want, we could look at checking transient errors. These could be typically errors that can fix themselves if we were to do like another retry attempt at doing a REST API call out to Supabase to store more upsert call summary that was performed by our LLM model that we got from the output. So let's check if response status code is in. Some of the transient error codes typically are like 429, 500, 502, 503, 504. If we want, we could like do a Google search on that to look at what those particular ones mean. I'll leave you guys to do that. And then raise runtime error. So you can just say encountered transient error failure on Supabase upsert call, and we could share status code. We'd also look at sharing the text. So then we could also look at, for instance, when we run into a hard error. This wouldn't be so much something that we could easily maneuver, overcome just on like reattempting to, send a REST API call, post request to do the upsert call summary. This we may have to go further into debugging the code and checking if there's any like logical issues and whatnot. So typically, these would fall under the 400 range. Just say base runtime, and we could say encountered hard failure on a Supabase upsert call status this text 4000. Okay, so now let's say we don't encounter failures above, success on REST API call, REST API upsert summary. We just return. Nothing happens. Now, if there is also like an exception that happens, we can use that last error to get the current error. We can check if our attempt is greater than or equal to self max retries. What we can do is we can break. And then this would be one of those cases where we're going to exit the upsert call method. We ran into an exception. One thing we can do is we could raise a runtime error again, or in our case, I could just create a print statement. 1 moment. So like let's say we don't run into that attempt. We haven't like maxed out on retries. One of the errors or transient failures we could run into is we do the requests post request too fast, faster than the Supabase is able to retrieve and address that request. So we slow down the next request that's sent. And we do it based on the attempt. So time sleep 0.6 times 1 plus the attempt that we're at. Okay, and for now, I'll just put a print, kind of just potentially ran into issue sending REST API upsert call summary Supabase. And that would be like after attempts. Okay, and what we'll need to do as well is create a table. let's see, create, nah. Well, I'll add it to the markdown, or no, I'll do it here. So let's say schema SQL, maybe. Well, yeah, we'll do DB. I'll put it there so it doesn't intrude with our main py. What I'm going to do is I'm actually going to move this over to my Supabase project that we created earlier. But first, I'll write it out here. So create table if exists call summaries, and we can say it's a part of the public database. We'll have a call ID text primary key. This will be important to prevent duplicates and to be able to address when we do have duplicates and how the resolution is set to like merge duplicates. And then we have summary text, not null. So what we'll see here with multiple of these column names is they're similar to the LLM result schema that we have. And what we'll see a little later is when I create the call processor class, it's very similar to the record schema. Okay, so got summary, intent, label, text, not null. And then we have intent confidence, double precision, not null, default, 0.0. And then we have key entities, JSON B for Postgres, not null, default. JSON B, then we have action items. JSON B, not null, default. JSON B followed by status text, not null, default. Set this to open. And then every time that we make an update to our Supabase table, we'll also have updated timestamp. It's not null, default, be based on now. So we can do that. Let's go create that. So we'll come back here, go into the SQL editor. We can copy paste that SQL code that we just created. We could run it. Of course, there's like a slight issue. What I will do is I will reference, actually, let's use the GitHub Copilot for this one. So what we can do is I can ask it, can you analyze my, can you analyze my public call summaries? Table, create table code. I tried. I'm gonna try to create the table in Supabase SQL editor. Ran into the public error. To solve it. So this should be something minor, most likely. So we can let that run, and then we can return to our Python code at the moment. Oh, that was pretty fast. Let's go back. So let's go into, we're in the call. Syntax error is caused by create table. In Postgres Supabase, the clause if not exists. Oh, if exists. Oops. Wait, what? If not exists, if exists. Oh, okay. Yeah, I just needed the not in there. That was the main difference. So we go back here. I see. I said create table if exists. Yeah, that was wrong on my part. It should be if not exists. Typo. Okay, so now we have the table that was successfully created. We can return back to our main, and what I can say is note created wrote SQL create table code in schema.sql script added to Supabase SQL editor. Okay, so yeah. Now that we have that, we're pretty much near the end where we can create our pipeline code, which is going to be the call processor code, and then we can finish off with the entry point, and then we can test all of our code. Yeah, we have the storage client. I'll update that real quick. So, later if we want, we can create other derivations of this class to all pretty much perform this kind of operation here. Sends update Supabase. One of them is the REST API call, which we do, and the other is to use Supabase Pi client. Of course, we could interact with another cloud database system as well, if we wanted. Before I do the pipeline stuff, let's also get that upsert URL. So before I do that, let's look at what is the Supabase API call or upsert. Conflicts. And you choose the name. Let's see. Like this. I mean, there is typically a on conflict portion. What is Supabase REST? What is Supabase upsert REST API call? I mean, this is part of it. Conflict. Yeah, this is more like what I'm trying to do. This is the similar one. So we can take that. We can update it. I'll just put a note here. This is the upsert call, REST API call. Yes, it would be like that, where we have our URL followed by REST v1 followed by the self table and the call ID, because that's the primary key. So we'll just update it like that. We'll let the code completion do that part. So we already had an idea what that was going to look like. Okay, so that was the main update there. And then the other is HF OpenAI compat client and the base URL. So the base URL is actually Hugging Face. We kind of saw it earlier in one of the tutorials or documentation pages that I had open earlier. Here it is. So this is what we pass to the OpenAI client to interact with the Hugging Face URL. Yeah, so that gets passed there. The token gets passed in. Pretty much have almost everything up to date. Now we have these last two portions, and we're almost done building our Python LLM application that will be able to summarize JSON transcripts related to the automotive and healthcare insurance call center or call centers. So we'll create call processor. Now that is a great code completion where we have the constructor, where we pass the LLM client and the storage client, again, because we have parent-child kind of class paradigm. So we can pass, of course, our child class objects to this. Then we can, initialize our constructor. We can, they call it process call event. We could shorten that to process. We have the call event. We also have, then a call where we use LLM client to call on summarize and classify. We pass the event, the call event, which contains like the transcript, the call ID, and so on. From that load, we get back the LLM result, which is that nice structured schema that we created. We also get back the raw, generated summary from model raw. And then we can create like a new record dictionary out of that. Which it pretty much contains like everything that was related to the LLM result plus the model raw. And then we pass the event and that new record to our storage client to do the upsert call, feature. So I will also disable the code completion for this moment. Just wanted to run through that with you guys, how code completion could be very useful, and then we can still learn from this experience. LLM client for the type hint, storage client, and we have self LLM self dot storage. We can then create a process method, and we can pass the call event, and yeah, matter of fact, let's just start there for a moment. This will be dictionary string any. We'll create a new dictionary for that. So what we will have is LLM results and the model raw. And we'll use our LLM, and what we'll do is we'll summarize and classify. Summarize and classify. Of course, we need the transcript. Go back, we check, takes call event. So we can pass call event, and then we can do the call ID, the the transcript, any of the attributes we might need from that. And we can also create a new record dictionary string. Again, we'll initially get what we need from the LLM result and then add in the model raw. Summary, results, summary, intent, label, intent, confidence. And what we have too is intent, confidence, and then key entities. Key entities, model dump, action items, column result, action items, status, status, model raw, and we just pass in model raw. So let's go check LLM result. Yeah, I mean, that's pretty much everything we need. Check the schema, double check it real quick. So we have the new record. We can now use the storage client we created, which was the Supabase REST upsert call summary, update our table in the Supabase cloud. So we've got self, storage, upsert, call, summary. We pass the event, we pass the record. That's pretty much it. And we can also retrieve the record. And we look at upsert call summary. We pass the event, we pass the record. And now this last part is where we're going to finally deploy our code. We're also going to be able to parse the real world transcripts data set, tailoring it toward the automotive and healthcare, insurance, call centers, and see our LLM model in action. So some of these, let me see. Oops. Some of these will be like import OS is not there yet. We'll do this at the top here as well, import OS. Okay, so we have import OS. The other one that we could look at soon is argparse from.env import load.env, because we're going to load the environment variables. We also have path. that we'll deal with down here. So from path lib import path. And then if there's any other import statements, we'll add them on the way. So we'll create a function event dataset JSON path. And this will pretty much be the path we'll retrieve the call event. And what we'll be passing here is typically the path of our transcript file. So path before we get there, we could have the object. So this would be, maybe it's like string object get, or no, not exactly. Hold up. So we got object, and then we have the path. We could do JSON loads, and we could read text encoding equals UTF-8, just like that. So we have our JSON object from pread, and then we can get the transcript, JSON transcript, pass in string, get JSON. In our case, we saw earlier that there was a text variable. You could strip the beginning, ending, trailing characters that are typically different white spaces. So we got JSON loads the JSON object. We got from the JSON object, we get the text. We then assign that to the transcript text. We also can get the call ID from key stem being. Yeah, I mean, there could be a case where the JSON in the JSON transcript file also contains like call ID or case ID metadata. So metadata could be empty, but we could also set valuable metadata that could be useful for the LLM model, like set like the ASR confidence, audio duration, redacted PII policies. And then with this, we would create the call events. And so we pass call ID, transcript, and we pass metadata. But then we just return that. Then we now create the main function. Of course, we have actual part of the main where we'll run that function. So part one, we could look at loading environment variables. Load dot environment path. Path is the file typically, and we resolve And now we're looking at, okay, where are we currently at? We're in the source directory. Where is the .environment file? It is in the root of our GitHub repository. So we just go back one directory. So we do parents one, and then we can say .env. So now part two, create argument parser and parse args. So we got AP, arg parse, argument parser, just like that. So one of the cases is add mutually exclusive group. And then mutual exclusive group would be similar to AP, just now like the arguments that we pass here, either one could be true, but they typically won't be used at the same time. Add argument. So what I'm looking at the moment is you have dataset JSON if you want to get a single JSON transcript file. Say expect top level text. The other would be the path to the directory of JSON transcript files. And then it's similar for that top file, top level, which would be text. And then AP add argument limit type help, which would be like number of JSON transcript files parse in dataset folder. Okay, and of course, what we could do, if later we needed to account for text transcript file, we could add an argument for it. Part three, create call processor. So by creating the call processor, this is going to allow us to feed our whole data pipeline, one single JSON transcript file or, multiple JSON transcript files that come from a dataset folder, which will be for us like the automotive and healthcare insurance call center, folder. Also, on a side note, we could actually further extend enhance the call processor kind of idea, leverage, minify C++/Python bindings, or go, the route of NiFi and, create custom Python processors where, we have a whole, data pipeline of processors. Okay, so what we can do, get the processor, call processor, and we're going to initialize. So we have HF OpenAI compat client. We also have storage, and that will be our Supabase REST storage. Okay, and now we have that. We can move to the next part, which is to work on parse the JSON file. transcript files in the dataset directory. And what this will be is we'll first check the args. Forgot to args equal AP parse args. So we can look at dataset JSON if it exists. Great. So then we can pass that into the path. Get the directory check exists or is a directory. So what that'll look like if the not D exists or not D is there. So if those are cases that happen, we can raise runtime error, kind of notify the user, must be directory. Or first I should say dataset error must exist and be a directory. So I mean, either of those cases we could have encountered where, you know, it was false and we ran into this. Okay, and so once we have that, we can then parse JSON file names, or I should say extract JSON file names. And so with JSON files, and we have P for we're dealing with the iter on the directory. So we got P for P in D, and then iterate on the directory. And P is file, and P suffix lower equals, oh, if, whoops. So we got for P in D iterate on the directory. Then after that, it would be kind of like for this, you know, we're looping across the directory of getting these files. Then we're checking the condition if P is file and P suffix lower equals JSON, then we'll create, you know, the list of JSON file names. So JSON, so we check JSON file names, we have the JSON file names, and one thing we can do too is check limit is greater than equal to 1. So if it's less than 1, we just raise an alert about that. If all is good, then we continue. Now what we can do is process and summarize JSON transcripts into processed list of dictionary. So first we'll just start out with like processed. We'll just do it like that. And dictionary will be an empty list. In the meantime, and then we can loop through our JSON files. JSON files, args. So we're gonna iterate across the JSON files based on like what we set the limit to, and what that'll be After that, it is going to be, we're going to get an event. We're going to use event from dataset JSON path. We have event from dataset JSON path, right? We can pass in our path. We have that. We also have the processor object that we created. So we can get the record by using our processor, then calling on its process method. And we can pass the event that contains the call ID, the transcript, the metadata. Once we have that, then we can append into our processed a dictionary for the path. We pass the path like that. And then the other is the call ID, which we can get from call event. And then from that, we can also get the intent label, which we can get from the record. So this would be like related to our taxonomy list. So this could be very useful if the domain that our automotive and healthcare insurance data set, if it's accounted for in our taxonomy list and we don't run into a case where it's other, then we could know like, okay, this path to our JSON transcripts and the call ID related to it and the intent label, it's more defined, more specific. I'll show you soon what we could do if we wanted to just show, a JSON dump of the record, like for a single JSON transcript that's been summarized. But this is the case for like when we're dealing with, multiple processed JSON transcripts. Something to keep in mind with this too, every time that our processor processes the event, it should actually go up to the Supabase cloud storage. Also, I forgot to mention, we can set this default to 5 for the limit. So we'll just send like 5 summarized transcripts, to the Supabase cloud. Okay, so we process that and we can print JSON dumps. So typically what we would want to look at printing is print JSON dumps would be like the count processed, items processed. So count, get the length of the number that was processed, and we can also get the items that were processed. And if things go well, we just return. So that's in the case that we're dealing with like dataset JSON. Not dataset JSON. I meant dataset dir. That's in the case that we're dealing with the dataset directory where we're parsing through the directory. The alternative is, let's say we're dealing with the dataset JSON. So the good news is by dealing with the directory of JSON transcript files, we pretty much already dealt with the JSON transcript files individually. So we can now just do that similar operation on one JSON transcript file. P path args dataset JSON, right? Yeah, and we get P. We can now get the event. We can call on event from dataset JSON path. We can pass P. We can also use the processor passing process, passing event to process to get the record. And in this case, what we're going to do is print JSON dumps the record. But I forgot to mention, when we're doing this, we can do an indent of 2. So we'll do similar here too. So the record is already a dictionary, so we can just do JSON dumps, pass the record, and then do indent 2. So the difference between these two approaches is if we wanted to see like the LLM model's summarized output for the JSON transcript, we could look at that individually, or we could just see even more brief like what the result looked like. All right, so now we should be in a state where we're ready to run the code. So if we were to Python source or Python path, let me see actually. So one thing we can look up is it would be something like this: Python path, and then the Python-m and the package and the script. So Python path, let's see. Python path. But first we go into LLM. Okay. Python path source Python m source in dataset JSON. So let's say we did dataset JSON first, and then for simplicity, I just took this exact path, right? Double check the argument, the way that they pass. We'll test it ourselves. It's fine. No module name dot environment. So that one's really just most likely a pip install dot environment. So we're gonna go through the process of none should be fine. And if we want to improve how we're getting the environment variables, we could also add gets as well to them. So we'll just some slight modifications. Those should be the environment variables. There's another note I can add for future improvement. Checks. Yeah, but we don't need to do that right now. OpenAI is not defined. Oops. So that's just from OpenAI, import OpenAI. Okay, and then this is the Supabase storage, which it says it's missing 3 those arguments. So for simplicity, again, I'll just add none and I'll add none. We have our environment variables here, so they should be fine. And we just added gets to those to make them a bit more robust to getting then. And so we have the event 304. Let's go to summarize and classify. For validation errors that are all coming from to have is a 404 error. Tells you where things happen. I mean, each of these we could say as, okay, those are initialized if we rerun it. So the problem came up because they were not validated. So when I check if the key entities is a dictionary, that was slightly wrong. So that is in lead coerce. There it is, and is instance. Request is not defined. That's also another easy one. Because what we can do is we can import requests. I think I already installed requests as well. Yeah, they're already satisfied. And time, we can import time if needed. All right, so we pretty much debugged the problem and we got the solution. So here you can see after I wrote all the Python code for the LLM application on the back end, I got to a point where we created the call processor. We fed the data into that call processor from the entry point, um, you know, main part of the function. We fed the single JSON transcript into our data pipeline through the call processor. Our LLM model, we ended up using the OpenAI, uh, client with a particular Hugging Face URL and model ID to then make a request out to it, the LLM model, to summarize the transcript that was related to the automotive and healthcare insurance, typically inbound. So that's when a customer would call the call center. Um, oh, and we can see here that there's a report that it says unable to parse transcript, requires manually review. Okay, action items review, the follow-up, the provider. So, I mean, if there was an issue here and it came from, using the model, because what we see is the content, right? And its new quote. We see reasoning. Then it really just comes down to an issue with sending the REST API upsert call to Supabase. So actually, we were able to, um, deploy the LLM model, like reach out through API request to the um, LLM model using the OpenAI client, have it, take our transcript, generate a summary of it. I mean, because like we can see the model raw, right? We have the provider, we have the model ID, we have the raw response. We can see the content of the summary. Customer is interested in purchasing a Mercedes. That's the content. The reasoning, we need to produce JSON with summary, intent label, confidence, key entities. And here's the generate text. Customer is interested in purchasing a Mercedes GLC. Request detailed outdoor price. So what we can do, since we ran into an issue with Supabase, we could look at increasing the max retries. We could look at, the timeout. Alternatively, though, we could try using, I kind of mentioned about using Supabase by client directly. So, what I'll do for this at the moment is copy this down for our reference, so we just have it. Create a log. I'll call it test processor. OpenAI client LLM let v1 log. So we have this for reference. And what we'll try is we'll just update, instead of using the REST API call, we'll use Supabase Pi directly. Or I should say Supabase. We'll use Supabase directly. So what we can do is Supabase storage. And so we can use the Supabase URL, Supabase table, Supabase secret key. We can create the client. And then we can override, like, so this is another derived class. So we have a different method for upsert call summary. It takes the event, takes the record. We can pass the record into another dictionary, make sure it's dictionary, and set the payload. And then we can have a payload with call ID associated. And then we can, use self client to call on the table, pass in the table we want, do an upsert on that payload, and on conflict would be call ID execute, and then if we want, we could look at potential statuses that we run into. Okay, so what we'll do is we will also, for now, pause the code completion. Of course, we can use table key. Supabase secret key. Oh, no need at the moment. The other one is going to be self client, and then Supabase. So I'm going to reference something. Yeah, so Supabase create client, and then we can pass in these parameters. Supabase. The URL and the key. It would be like that. And then we have our upsert call summary event, call event, record, do the payload, dictionary, the record, payload, call ID. No need for headers or that. One thing I can do is just double check with Supabase Python upsert call. Yeah, we create the client, we got the URL, we got the key. We already have the data. So we could call Supabase table, upsert, and the data and execute. So Supabase table. So it's just a response Supabase table, Supabase table, and we know what our table is. Supabase table, upsert. Upsert. Our payload. Be like that and execute. That would be pretty simple that way. And then there's on conflict. So we can response data. Let's see. So successful. Observe response from Supabase clients. And we could do that. We can try self-client where we pass our table. We could try this. Supabase storage client. We'll keep, you know what, yeah, we'll stick to that. And I'll put a note. So to do, we should check why Supabase REST API call was failing. But I want to try two different approaches to see if I resolve the issue. Yeah, it'd be here in the call processor process. So we're going to try this one instead. And it should be the same aside from just the method that's used. And I should have a table that's created. Yeah. And so we can try that approach again. So we got could not find model raw column. Oh, interesting. Let's add that. That could be something that was missed in when I did the upsert call over Supabase REST API. It could be that that was missing. Of course, I can double check the logs too. I'm going to say here another one. Test OpenAI client Supabase client. Say Pi client script 2. Yeah, let's go check that table. Maybe I did forget the model raw in the table. I totally did. I totally forgot it. Let's see here. We can delete the query. Easier to do it that way. Go back in here and do model raw JSON B, not null default. Yeah, I mean, this is what I was going to do. So model raw JSON B, not null default, and JSON B. And then we can bring this back into Supabase and we can run this code. Yes, no problem there. We can refresh this. So let's go back into the table. Create AH call summaries table. Okay, so that's what that one was. This was very helpful compared to the Supabase REST API call. Let's see. We still got model raw. Ran into an API error. Let me double check that because this could be, I just created, let me see here, this one. Go into the table editor. We go in here. Oh, this was the old table. Yeah, this was definitely the old table, not the one that I wanted. Let's see. Delete the table. So we'll delete the table. We'll go back in, go into the SQL editor. This one is the one we want. That's why we saw, I think that's why we saw that error. We come back in, we go here, check the table again. We see model raw. Another way that I could have done this in SQL directly was from the SQL editor. I could have did select star from all, and I could see like what's currently in the table. So let's run this again one more time. And it looks like it's what we expected. The upsert works successfully. The nice thing about Supabase's Python client is it showed more information for us. So, you know, if we go back to table editor here, oh wait, it's empty. What? I will see what this printed out actually. It looks like it worked fine. Maybe it didn't make its way up to the table though, or something. Let's do a version 2 of this guy. It's the OpenAI client. The good thing is it looks like the OpenAI client that then, you know, makes a API request out to Hugging Face where our model is currently, you know, located. It is able to make the request out to the LLM model, get the output, which is the summarized, you know, transcript. Test OpenAI summary. OpenAI client, Supabase client. It's version 2, version 3. I want to check is to just verify generated text is there. Oh, it's unable to parse transcript, requires manually review. Oh, well, we can continue debugging this. Summary unable to parse. Same problem happened. All right, well, I'll need to continue debugging this, but this pretty much is, you know, the point of we were able to build a LLM application with Python. We were able to make a request out using the OpenAI client, make that request out to Hugging Face's, you know, inference providers, and specifically choose our model ID related to OpenAI for one of their GPT models. I believe it was 120B. Get back that LLM model's output, and then try to you know, make an upsert call summary to update the Supabase storage, and we just ran into an issue. But I'll keep debugging it, and I'll get back to you guys.